students. Today we will study about inductors. Okay, now let's move to the first slide. Okay, yeah. In this today's session, we are discussing about what is an inductor, its symbol, its formula, its structure, and what is inductance, and what are the functions and what are the applications of inductance. Okay. Now, first we need to know what is an inductor. Okay, look, you see here, this is the figure of an inductor. Okay, what is an inductor means? Inductor is an electronic component which is capable of storing energy, and the energy stored is in the form of magnetic energy. That is a point you know. We have studied about capacitors in the last class. Capacitors also stores energy. Okay, but the difference here is inductor store energy in the form of magnetic energy. Okay, it is in the storing in the terms of in form of magnetic energy. That is you need to know. Okay, inductor, as I told, it is a passive electronic component. It is an electronic component. It will function of this inductor is storing of the energy. That is, electric energy will be stored in the form of magnetic energy. Okay. Now we need to know about the symbol of an inductor. Look here, this is the symbol of an inductor. Okay, we have studied the symbols of resistors and capacitors also. Like that, similar that here, this is the symbol of an inductor. Okay, okay. Now coming to Ohm's law, we have studied Ohm's law in the last class. Okay, this is the we studied that V equal to IR is the Ohm's law, general Ohm's law. But here, in case of inductor, we know that the Ohm's law is V equal to L into di by dt. This is the equation of Ohm's law in the case of an inductor. I'll explain each term. Here V is, as we already studied, V is a voltage across the inductor. Okay, L is the inductance. That means here we can say that here the voltage is directly proportional to rate of change of current. That is a point you need to know. Voltage in the induced in across the inductor is directly proportional to. That means when current varies, rate of change of current, when that varies, voltage also varies. Okay, it is directly proportional. Or in other words, when voltage varies, rate of change of current also varies. Okay, so in order to changing the directly proportional symbol into an equal symbol, we have added an constant, that is L. L is known as inductance. Okay, and that unit of inductance is henries. Okay, that unit of Henry. Okay, then as I told, di by dt is instantaneous rate of change of current. Okay, now coming to what is an inductor means. An inductor is simply, look here, a coil. Look, a coil wound. Look here, this is a figure of an inductor. A coil is wound and a supply voltage is provided. Okay, this is the this represents the number of poles. This is a cross section area. Okay, then this is the material, core material. Okay. Now coming construction of an inductor. Inductor consists of coil of conducting material, as is shown in the figure. This is the coil, and this material will be conducting. Okay, coil of conducting material. It is generally we use insulated copper wire. Okay, and this copper wire will be wrapped around a core. Look here, this is a core. This is the core, and this is the copper wire. Okay. And either this core is of plastic or plastic material we are using, okay, or ferromagnetic material we are using. This core is used above core will be of plastic or ferromagnetic material, and this wire will be mainly copper. Okay, then if we use this ferromagnetic material, then this is known as iron core. Okay, that's it. Okay, now coming to the principle of inductance, or how this inductor is working, that we need to know. Okay, basically what we can say is it is uses a conductor that is wound into a coil. As I already told, it is a conductor, that means a copper wire wound around a core. Okay, and when electricity flows into the coil from left to right, this will generate a magnetic field in the clockwise direction. Okay, that means when current flows, okay, this is the figure. Okay, when we connect a voltage across this, okay, what will happen means current will flow from the left to right in this direction. It will go in this direction and the current will flow in this direction. Then what will happen means in the clockwise direction a magnetic field, look at this is the magnetic field represented, this magnetic field will be generated in the clockwise direction. Okay, that you need to, when we, this is a core, this is a copper winding, when we provide a supply voltage, then when the current move from left to right, at that time what will happen, magnetic field will be generated. We know that when current is passed through a conductor, we have a magnetic field. When the current passes from left to right, then the magnetic field will be in the clockwise direction. Okay, then if we increase the number of turns, look here, the if we increase this number of turns, a stronger magnetic field we will get. Okay, if the number of turns are increased, then strong magnetic field will be generated. Okay, a strong magnetic field, we can generate this strong magnetic field by another method also. That is, we can increase the cross-sectional area of the inductor, or by changing the core of inductor. We can increase this area. This is the cross-section area. We can increase this cross-section area, or by we can change this core of the inductor. We can change, so that like also we can increase the magnetic field of the inductor. Okay. Then calculation of inductance. We need to find what is the inductance value. For that, this is the equation, L equal to mu into K into N square into S by I. I'll explain each term. Look here, that means here mu means magnetic permeability. Okay, it is a term, magnetic permeability. K is a constant. This Nagaoka constant is a constant. Okay, then N is the number of turns, S is the cross-sectional area of constant of the coil, and I is the length of the coil in this axial direction. Okay, just don't worry about this constant and all. This K will be having a particular value. That's it. Okay, nu is the magnetic permeability. Each means wire will have different particular permeability values. This will vary when we change the coils. Okay, that you need to know. Okay, then this is the equation of the inductance, L equal to mu into K into N square into S by I. Just remember this equation and what these are represented. Okay, then we need to study what is the use of an inductor. Okay, there are some of the uses are shown here. First one is inductors can be used in the tuning circuits. In electronics, we are using some tuning circuits. Okay, in these tuning circuits, we are using these inductors. Some sensors, some sensors are based on these inductors. Okay, that also you need to know. And as I told, this it will store energy in the terms of magnetic field. These inductors can also use to store energy in a device. Okay, then inductors are also used in some particular motors. Such motors are called induction motors. Okay, then another one is inductors can be used in transformers. Okay, we'll study that in later. Okay, then inductors can be used as filters, and also it can be used as chokes. These are the things that you need to remember. Okay, then look here, this is look here, the coil is wound in a circular shape. Okay, two application of inductors are used as I told, filters and sensors. These are major applications of it can be used for storing charge also, but major applications it is used for used as filters and sensors. Okay, now we need to study various inductors present. Okay, just you need to learn these names only. Okay, there are air core inductors, iron core inductors, ferrite core inductors, iron powder inductors, laminated core inductors, bobine-based inductors, toroidal inductors, multi-layer ceramic inductors. These are different type of inductors. Okay, now this come to the end of the presentation part. Now let's go to the some practical exercise using this inductor. I will explain what is an inductor in the TINKERCAD. Okay, now I will change my screen. 1 second. Okay, now I will change that screen. Okay, 1 second. 1 second. Okay. Okay, now I am in the TinkerCAD page. Okay, now we can, I'll show you what is an inductor. Look here. I will first search in this TinkerCAD, I will search what is an inductor. Okay, you can find an inductor here. Okay, this is an inductor. Okay, I hope this is visible. Okay, this inductor simply it has a core, and as I told, it has a core and a copper winding. Mainly copper is used to for as a conductor for winding around this. Okay, and as I already told, these are mainly used as sensors and also for so filters and all. It is mainly used. It can also be used to store energy in the form of magnetic field. Okay, then what will happen, because when we supply a voltage, then as I already told, I'll explain this concept. That means what will happen means when current pass through a conductor, a magnetic field will be generated. Okay, when this current is passed from terminal 1 to terminal 2, the magnetic field will be in the clockwise direction. If we connect in the opposite direction, then the current will be in the anti-clockwise direction. Okay, now then what I will show you means we can connect a battery and I'll explain the concept. Okay, okay, I am taking this 1.5 volt battery. Okay, I'm just connecting to the two ends of this inductor. Okay, from here to here. Okay, now when we since we have not connected any device, I will say what will happen. Okay, look here, when I click on this chart simulation, what is happening is our current passes from this port. 1 second, there is a this I will say here I have connected negative to this side and positive to this side. Then what will happen when we connect? Okay, from left side I have connected the negative and the right side I have connected the positive. So here what will happen, because the current will pass through the coil that is wounded around the core. At that time, what will happen? A magnetic field will be generated. Here we connect the this inductor in such that here in the terminal 1 we have connected negative and positive we have connected terminal 2, so that this current will be passing in this direction. Okay, in this direction, so that there will be a there will be generating a magnetic field. Okay, this magnetic field will be in the anti-clockwise direction. Okay, clear? Okay, now we can connect this in the opposite direction also. Okay, now what will happen, I would say I am connecting this negative to terminal 2 and positive to the terminal 1. Okay, now when I click first, we can always remember that we can give this color, we can change the color. We should always connect the negative as red, red one like this, and we should sorry, positive as red and negative as black. Okay, positive as this red and negative. Okay, negative, look here I have connected as black. Okay, now positive as red and negative as black. Okay, now when I give this chart simulation, what is happening, because the current will pass through the coil and now the current is passing from left to right. Okay, then what will happen, there will be there a magnetic field will be generated, and this magnetic field will be in the clockwise direction. So I hope that this concept of inductor is very clear for you. Okay. Now this is the basic exercise. Okay, now you should do this exercise on the your TinkerCAD account, and if you have any doubt, please contact. And I hope you understand this. If you have any doubt, please ask. Okay, then we can stop the today's session, and thank you. Okay, bye.